Started.
All right. Hey, thank you very much. So, yeah, I get to talk to you today about securing the enterprise network, and really the point of this conversation is to start drawing out the value of the network itself in the role it plays and the role it should be playing in addressing the security challenges in your network. And then Chris Smithy is joining me today, and we're going to be back and forth a little bit with some color on some of these slides and really bring out the value. One of the key points here is the NetFlow data, which we'll get into some detail on the value that comes from NetFlow, and then how Lancope can give you alerts and drive value out of that network data. So from an agenda perspective, I'm going to kick this off a little bit with some security market trends and talk a little bit about what our customers are seeing today. We'll get into the threat-centric security model, things you should be doing before, during, and after an attack, and talk a bit about a portfolio approach to addressing the security concerns. And then a little bit of new information, the role of the network for security, the importance of using the network to complement some of the traditional approaches or advanced malware protection approaches you might be using in your network, the role the sensor, the network can play in its role as a sensor, as an enforcer, and as a mitigation accelerator, and high-level value of how we can bring the network in to assist with the security challenges. And so, to kind of start this off and set a tone for this, Cisco puts out an annual security report. The 2015 mid-year report was announced recently. One of the earlier ones, 2014 report, we looked at a lot of our customers out there, and of the base that we looked at in that report, we saw malicious traffic, and that is users attempting to reach or download from known malicious sites visible on 100% of the corporate networks we were working with. And it's a huge challenge here because everyone is affected by malware and other attacks on their enterprise network. And it's changing the way that people are trusting what's on their network. Whether it's the applications that users are running, the certificates you're leveraging to secure, the cloud itself, the applications and resources you might be using or storing in the cloud, users' devices, even the users themselves. And what we've seen and what we've heard from the first is a CIO of an investment bank, second is a senior executive from a global search firm, is that they're changing the way they treat things on their network, and they're treating every user as hostile because they don't know whether that identity has been stolen, they're using stolen credentials, or maybe that user might even have malicious intent. And ultimately, they're treating every enterprise and the entirety of the enterprise as untrusted. And so that's a big shift on how you look at what's on your network. And it leads you to a conclusion that network security is critical. One of the things the network gives you is the visibility down to the devices, the users, the locations, the applications on your network. And it's a critical piece of the puzzle that, frankly, people aren't using enough of right now. And so we want to talk a little bit about how to bring the network together with the traditional approaches to security. Now, from an influence perspective right now, we've got a couple big ones happening. And first of all is the enterprise attack surface is increasing. There's a lot more on the network that you need to protect. The threats themselves are getting much more difficult and much more difficult to detect and much more sophisticated. And mitigating this, removing it from your network, moving it from devices is frankly too slow and complex. And if you look at this enterprise attack surface, a couple trends here. First of all, a lot more devices per knowledge worker, an average of 3.3. IP traffic, increasingly mobile, 55%, and billions of application downloads in 2014. From a cloud perspective, hundreds of cloud applications being used per organization. Cloud traffic is growing 3x by 2017, and the annual cloud workload growth is around 44%. And if you add on to that these conversions of the OT and IT space with the Internet of Things coming onto the network, we've got over 50 billion connected objects expected by 2020, and a huge growth in machine-to-machine IP traffic. The importance of all this is that there's a lot more to protect. There's a lot more devices on your network. There's a lot more traffic on your network. Frankly, there's a lot more things being brought into the network that each one of these presents an opportunity to attack and an opportunity to monitor and protect. The next piece of this is that hacking itself and cybercrime has evolved, and it's evolved from the early approaches with kind of system-based viruses, moving towards phishing attempts. You know, this takes us to where hacking becomes an industry where we actually have a multi-billion-dollar business now of people attempting to hack. It's become a global industry where sophisticated attacks are being rolled out, and literally you can go out now and contract an attack as a service and get developer kits where you can write custom code to go out and attack. And we've seen this move from viruses all the way to the point we're at today with advanced persistent threats and cyberware. The net behind all this and this progression is that, frankly, the criminals are smart, and they're getting smarter every day. And they're learning to, in fact, just learn and write custom software where they can learn more about your network than maybe you even know. They're writing malware that gets in, the initial malware, might lie dormant for a long period of time. It's going to listen. It's going to collect information about your network. It's going to learn vulnerabilities. Custom malware based on that information actually is going to be developed to further attack your system after learning those vulnerabilities. It's a huge challenge we've got right now.
You know, just a quick point of commentary here from me too on this. One of the things that we've noticed over the course of the years is that the specific types of attacks are pretty similar now with APTs. The nuances and whatnot, they've made a lot of refinements to the way that the attacks happen. But if you look at the way that the life cycle's changed over the years, you know, we had propagation of events with viruses, malware, things of that nature. The desire to spread through the network has always been there. One of the big differences we see these days, which creates problems for a lot of the traditional security appliances, though, is that the rate at which they want to do that has functionally changed, right? You know, if we looked at worms spreading throughout the early 2000s, that was a really good example of the time of how malware would propagate through the network. You know, the one advantage we had as security practitioners at that point in time was that worms wanted to spread as quickly through the network as they possibly could. The drawback to the attacker for that was that while they got a lot of machines infected very quickly, because of the rate of expansion within the networks, it was actually really easy to detect that type of attack within the scope of the network itself because it was so noisy. It brushed up against a lot of the security devices that were found within the scope of the network. Now, attackers are still using those types of propagation events, but they've scaled down significantly in terms of how they propagate through the network, right? Instead of doing high-speed reconnaissance in the network, you know, they don't do open-air scanning within the scope of a network anymore if they're a smart attacker. They scale that down, and they only touch a couple of devices within short periods of time, and then they go dormant for a little while, and they come back a little bit later, and then they touch a few more devices in a different segment of the network. And that type of low and slow type of movement is very difficult for traditional systems to be able to identify for two reasons, right? One of them is that we just simply as practitioners can't afford to have probe-based devices in enough segments of the network to hope to catch that activity. But the other one is that most of those typical devices aren't keeping enough history to be able to see that this is atypical action, right? If I only brush up against 8 different systems in the scope of a scan over an hour, now that doesn't look suspicious to a packet inspection type of device. You really have to have something that's doing modeling of network behavior to try to predict some of those types of trends.
Absolutely. And the other piece of this puzzle, of course, with that brushing against and with the information we want to gather is that the attackers are fast, and frankly, we as defenders are too slow because discovery takes a long time. 60% of data stolen in hours, breaches remaining undiscovered for months. As we said before, companies connecting the domains that host malicious files and services. Behind this, though, is we're seeing, frankly, it takes a long time to discover and then an even longer time to resolve. And one piece of information from the Ponyman Institute was that it takes 80 days to discover these attacks in the new way that they're happening today. And then an additional 43 days on top of that, or 123 days to resolve. And these are numbers that we have to address because, frankly, they're too big. And how can we help speed this up is part of what we're going to get into in this conversation and really decrease the time it takes to discover this when it's taking place. So threat mitigation, remediation takes a long time. So strategic advice here, unite the forces. We want to bring together the approaches that you're using today, whether it's advanced malware protection, whether it's the threat-centric security and perimeter security, and bring those together with using the network and using the network in its role as a sensor, as an enforcer, and as a mitigation accelerator, or the three areas I talked about before that we're going to get into. And we like to speak to security and the challenges in the context of what you can do before an attack. When you're attempting to discover the attack, you want to enforce your security policies. You want to harden the environment against attacks. What you do during an attack, whether you're attempting to detect it as quickly as possible, you're attempting to block the effects of it, and then defend against it while it's in progress. And then after, where you're attempting to scope what actually happened, contain the effects of it, and then remediate it. Well, the network comes into play here across these three areas in different ways. As a sensor, it provides a lot of information before, during, and after. As an enforcer, it's going to help you harden the environment and set up the rules to protect against threats. Then as a mitigation accelerator, there's a lot we can do in the network to take the network remediation time, whether you're simply writing an ACL or rolling out a new complex policy, and shrink that down from what is oftentimes a manual operation to something that can be very automated on a global scale. So we want to provide additional visibility and defense across the entire attack continuum and leveraging the network as security, and the network as part of the security puzzle. And so introducing the first part of this, the network as a sensor. And in high level, conceptually, what we're talking about here is if you don't know what's on your network, it's hard to protect against it. And so the network can give you deep and broad visibility of what's on your network. And if you look at this, you've got everything from the devices on the far left, switches and routers on the right, and maybe some of the services, cloud or otherwise, that they're accessing. And if you don't know what's on the traffic, it's hard to, you don't know what this traffic is, it's hard to protect against malware. And we want to pull that veil back and see at a very granular level between devices in the network, what are known applications and what are unknown or otherwise known malware. And we want to be able to see this both on a very granular basis between devices, but as we all know, we've got global enterprise networks in play here, and we have to be able to take that information that we capture and know at a very granular level between devices and roll it up broadly across the entire global network that many of us have got to deal with on a daily basis.
Talking into mute, so I'll add a little more commentary here as well. I think, honestly, Cisco is a bit modest when it comes to the type of visibility that they can provide here. One of the unique reasons why we're partnered with Cisco to be able to help deliver this solution is that Cisco, particularly from the route switch environment, is uniquely positioned in the marketplace to provide all of the data about the transactions that are moving through the network, right? Cisco provides an unsampled visibility into those particular segments. We get to see every single packet that moves through the routers, the switches, the firewalls that are moving through that network. And when we talk about being able to identify security events, especially the small scale type of events that are so important to solving this type of persistent threat or insider threat or highly targeted threat that we face in the marketplace these days, it's essential that we be able to see every single transaction to be able to make those determinations. When we're talking about small scale events, it's extraordinarily important for us to be able to see all of these packets, and Cisco's uniquely given us the facilities to be able to do that.
Thanks, Chris. In fact, let me give you a bit of a highlight of what we deliver from this network as a sensor perspective. And the first one is all about detection. Looking for those anomalous traffic flows, looking at the malware as it tries to get in your network, spread across your network, it tries to touch other devices, tries to communicate with malicious hosts. We want to detect that. We want to detect that quickly. We also want to start looking at granular detection all the way down to the application usage and look at the behavior of users on the network and whether they're violating user access policies, so that when we have a contractor lose their credentials and enter your network, we don't have their ability to touch other parts of the network. And then we want to be able to detect rogue devices. So if someone tries to introduce an access point or something else to your network, make sure we detect that and make sure we can do something about that. And so from a sensor perspective, across those different areas, there's a lot we can do for the devices, the traffic, the applications, the users, and ultimately the malware that you might be seeing on your network. And just a high level to kind of give you an idea of the scope of this, we can look for those rogue access points. Capability we've got called a wireless security module lets us be able to see those, and so that we can then alert on those. We can look at devices when they get on the network if they're non-compliant with our device sensor and our ICE capabilities. And then we can actually look at devices on the network with the raw data from NetFlow and the alerting and higher level information we get from Lancope, and start seeing some interesting things about when devices start, if you will, frankly, doing stupid things on the network. We can dial down their reputation, and we can actually look at them as they behave over time and see that reputation change and resolve that with those devices. From a traffic perspective, we can start looking at traffic pattern anomalies. And so leveraging the information you get from the switches and routers with NetFlow, sending that information to Lancope for the alerting we can get from Lancope to be able to drive value out of that traffic. And then with NBAR2, actually getting down to what is the end application that's being used and actually being able to identify applications on the network. We can know a lot more about that traffic and leverage that information from a security perspective. We can detect distributed denial of service attacks. We can prevent against them a little bit with the clean air policing capabilities of our infrastructure, be more resilient against those. Clean air helps us on the wireless side. We can look at the source and path destination. So when those advanced persistent threats are on our network and impacting us, NetFlow, again, is going to give us that raw information. We've got Lancope to be able to draw value out of that with the alerts, and we can leverage ICE also to detect that source and path information. Malware, again, when there's that command and control communication that's happening where malware gets into your network and it's reaching back to that command and control infrastructure, you want to be able to detect that. And again, NetFlow and Lancope together give us the raw capability to be able to detect that and detect that quickly. Again, from an application perspective, we can look at the behavior anomaly of applications themselves all the way down to, again, this deep packet inspection and identify those applications on the network that are being leveraged. From a user perspective, we can look with our Identity Services Engine, or ICE, added in with TrustSec from a segmentation perspective, and watch with a role-based and user-based access violation detection what users are actually doing on the network and whether they're trying to reach resources that they shouldn't otherwise be reaching. And then from a malware perspective, there's a lot we can do on-premise and in the cloud, whether we're trying to detect email and web malware with our ISR routers and cloud web security, with intrusion, advanced persistent threats, where we can bring in capabilities in our infrastructure such as our IPS module with SourceFire Next Generation IPS and with our wireless IPS. And again, we can look for the propagation of that malware with NetFlow and Lancope together, for that malware exfiltrating data, again with NetFlow and Lancope together, and then get some of that early warning intelligence where we can look across different customers with the Cisco security intelligence operations and see what's happening with other customers and leverage that from an early warning perspective to help on a global basis. And so this is kind of a bit of a meaty slide getting into the network as a sensor and some of the capabilities across those five. But when you get to the heart of it, NetFlow keeps coming up. And if you're not as familiar with NetFlow, you can think of this as like a very powerful information source, kind of like your cell phone bill you might get at the end of the month. And what it's going to tell you is for every conversation on your network, for each and every network conversation, for all those flows, what's going on? Who's talking to whom? What's the source and destination of those flows? The IP address, ports, time, and data. And it's kind of like metadata of what's happening on your network that can be stored for future analysis. Very, very granular. Now, why this is important for security is that it helps you understand what's on your network, and it's going to help you identify things that are out of the ordinary and identify that anomalous activity on the network. And when you store this, you can actually roll back and roll forward and reconstruct attacks as they took place and take a look at, from a forensic perspective, what actually happened. And to Chris's point before, there's different approaches to NetFlow. The one that we've got is a full-based approach where you're capturing every flow. There are other sample-based approaches which are less useful for security. So you want to look towards that kind of a full-based approach for NetFlow so you're not dropping these network flows, which essentially become attack signatures. And the network itself can alert you to this anomalous activity. And this is the raw information that the infrastructure, especially with Cisco equipment, if you simply turn it on, is available to you on existing infrastructure that you likely have in your network today. And then on top of this, this is where we bring Lancope StealthWatch on top of this, because we need to do something with that raw information. And Lancope itself ships with hundreds of alerts out of the box. Many of them focused towards security, 7 of them called out on this slide, where that NetFlow data is sent to Lancope StealthWatch, and then with that product, we can then look for activities on the network, whether it's network scanning, when the scanning's happening up and down IP addresses or ports, we can get alerts based on that. We can look at those denial of service attacks. We can look again to the previous conversation, that reputation change of devices when they start doing things that indicate that they might be compromised in the network. We can look at botnet detections, fragmented packet attacks, the propagation of worms across the network, or even when ultimately that data that's been captured by malware that's been sitting on your network is trying to be exfiltrated and being sent out of the network. These are all things where we essentially take that raw NetFlow data and then apply alerts on top of it so that you can very rapidly understand when things are out of the ordinary on your network, and take that 80-day window that I talked about before and start shrinking it down and notice that this behavior is happening. In fact, we're doing a lot of work with Lancope StealthWatch right now. We've got a number of different bundling activities we're doing, frankly, with our hardware and Lancope together to encourage the behavior of turning on NetFlow, leveraging a product, Lancope StealthWatch, and getting some value out of the network and the information, frankly, that's there right now and available to you. And we want to make sure that people understand that it's there, and it needs to be just turned on and leveraged.
Yeah, one quick clarification here as well. So I like the analogy that Brian gave in terms of network flows being attack signatures. I think that's very valid in terms of the unique transactions are almost an indicator or a signature of a particular type of potential bad activity. One of the things that we try to do in the marketplace to help differentiate is that if you look at all of the raw events in terms of network flows that could be an indicator of potential bad, let's say it's an incomplete connection or a TCP reset, that could be bad, it could not be bad, it does match a signature for a potential bad. The magic sauce that really StealthWatch and Lancope bring into this particular picture is the ability to take all of those unique little flow-like signatures and then do behavioral analysis against it, right? So we take the onus off of the operator to determine which of those particular transactions that could be bad are bad by saying this is an atypical usage of this particular type of attack vector, right? Some amount of incomplete connections is normal for any particular device on the scope of a network, because probably most of us use Windows networks, right? It's sort of common these days. Broken connections happen, whether that's a result of a flaky WAN link dropping a packet, whether that's, it could happen for any number of reasons. But as we start to see that the norm is, maybe it's 10 incompleted connections over the course of 2 or 3 hours. And today what we've observed is 100 incomplete connections over the course of 2 hours. That might make it an interesting event in and of itself, but as we start to couple other types of suspicious activity that we identify through these types of indicators, we bubble that up to the operator to say, this is why you should be concerned. We've noticed atypical file transfers between this host and some of your sensitive servers after an event where there was some level of low and slow scanning activity that occurred within the scope of the network. It's all about taking those types of very detail-oriented attack signatures built off of flow, and then doing the analysis against those to say which of these should you actually be worried about. All right, let's separate the wheat from the chaff.
Yeah, and if you look at this across an attack, where if you go through the stages here, where you're looking for vulnerabilities, installing malware, connection to command and control systems, spreading malware to other hosts, or data exfiltration, we want to be able to detect all those activities. And if you look to the right side, the NetFlow data is going to give you the raw data to detect these. And then on top of that, Lancope StealthWatch comes in, like Chris just said, to start giving you the value from that information and shorten the time it's going to take from an alerting perspective and understanding what's this out-of-the-ordinary behavior on your network, and alert you to that and get you information about that very quickly.
One more quick point of commentary here on this. So, one of the things that I think is important to understand about that list that Brian's got there is that when we talk to buyers within accounts, there's lots of different ways that we can classify threats or attacks. And if you look at items 1 through 4, those are definitely different types of attacks that are meant to carry through a threat against the enterprise. So when I use the word threat to talk about what Lancope helps to solve in terms of problems, I'm really talking about the business threat, right? And the business threat here that's present between all the points that are on this page is that item that's down there at number 5, right? The concern to the business is that we're going to lose critical data. Maybe that's exposing PCI information to the outside world, right? We don't want to get the call that, hey, all of a sudden, all of our user information for accounts that we handle for external parties is published out here on the internet. We don't want to know that all of a sudden our email servers were compromised and sensitive information about all of our accounts and inner workings as a company has been pushed out here onto the internet. That's the business problem. We want to mitigate the potential for us to expose all of the elements that are core to our business or core to our intellectual property don't leave the network. Now, the cool part here is that when we start talking about the ability to mitigate those threats, all the steps above item number 5, right, that 1 through 4, if we can mitigate the overall threat at that stage, right, if we detect the attack whenever we're doing the initial exploration of the business, we've effectively mitigated steps 2 through 4. If we find it whenever that initial type of spread within the scope of the network happens, we've mitigated again before we get down to the data exfiltration. Same thing with command and control channel. So really what we're talking about doing is pivoting the point of presence so that we can find the early warning signs in an account, right? To the point earlier, accounts are infected. 100% of Cisco's surveyed accounts had malware that was inside of that environment. We have to operate at this point in time with the assumption that we're already compromised and that we don't know where it is within the scope of the network. Flow data, when we start to do this analysis against it, and when we have the type of visibility Cisco can supply, is really what's going to enable us to find the early warning signs of those particular attacks. We're not going to be able to keep them from getting in. That's an assumed threat. It's there already. But what we can do is contain where they are within the scope of the network. We can find out where they are, we can see the early warning signs, and hopefully we can mitigate before they get to step 5, before we lose our data, before we create a significant exposure that puts us into the news.
Absolutely. If I was to kind of summarize this at a very high level, you need to know what's on your network. You need to know your normal state. Leverage the network as a sensor. Drive it down to information that gives you about that traffic, about your network flows, what applications are being used, what devices on your network, the users themselves. Understand your baseline, and then be able to take that understanding of your baseline and for things that are out of the ordinary, react very quickly and understand what you should be doing there. But the base of it, though, is you need to know your baseline information about your network. You need to know the normal that you're experiencing on a regular basis. Now, shifting to the next step here, network as an enforcer. And so we talked a little bit about a sensor so far. Let's talk a little bit about what we can do from an enforcement perspective. And from a top 3 sort of capabilities here, number 1, you need to segment that network. Whether you're using traditional approaches or a role-based approach with TrustSec, we need to segment the network to contain attacks to take place so they don't see a broad set of resources on your network to begin with. The next part, where it makes sense, encrypt the traffic. Encrypt the traffic between network devices on the network to protect that data you've got on your network while it's in motion. And the third piece, secure the branch. There's a lot of opportunity out there to leverage direct internet offload for lower price connectivity or higher bandwidth, et cetera, on the branch. We want to take that and secure it. So coupling capabilities such as our IWAN capability, intelligent WAN, and then combining that with security such as cloud web security, where we can do that email, we can do that web filtering and give you the benefits of additional network access, but with actually more security in the branch. So a little bit on these. First thing, from a segmentation perspective, we want to divide up the network to better defend it. And we're going to segment that network to contain attacks. A lot of capabilities here. If I'm looking at segmentation, there's a traditional approach and then a role-based approach, we'll talk a little bit more about where. With a role-based approach, we can look at the users on the network and what resources they're allowed to see, so that a finance user can see financial data, a marketing user can see marketing data, and the two will be blocked when they attempt to see each other's resources because of how you tag that data, the user, and what they're trying to reach. And so we can do not only traditional approaches with, let's say, ACLs, where we're segmenting up the network that way on the switches, and then a role-based approach where we can identify users and allow or disallow behavior on the network depending on who they are and what they're trying to reach. From an access control perspective, though, we want to take this down to a very granular perspective. And with ICE, or Identity Services Engine, we can actually set up policies that say, if you've got, let's say, allow bring your own device, I've got a tablet that I want to bring to the office. As I move from, let's say, a corporate location to a coffee shop, I can actually drive what resources I'm allowed to see based on what device I'm using, what location I am, whether I'm, again, on campus or off campus, the network time, the time of day, or network type and time of day. And that way I can create a policy that says, maybe there's some data that you're allowed to see on campus, but maybe if you go off campus, I'll allow you to see email, but not other applications, perhaps on the network. We can, of course, drive this down to the physical and virtual level. And then the important thing is when users are coming into that network, whether it is via wired, wireless, we want to be leveraging Identity Services Engine, again, to drive that user-level capability on the network, to drive policy based on the user. And then, of course, unified access switches, which combine both wired and wireless on the same piece of hardware, allow you to get a more consistent approach to these policies on the network. And just a little bit on TrustSec. So, as I spoke to before, high level, if you've got a policy that describes who can talk to who on that network and who can access certain assets and how systems talk to each other, we can kind of set up a table that's kind of an allow-deny, basically based on the employee in this case, or what system you're accessing, what you're allowed to see. And it dramatically simplifies access management because you're no longer worried about the physical network. You're no longer worried about whether they came in wired and wireless. You're really looking at who they are, what their role is, and what they're allowed to see from a policy-based perspective across the infrastructure. And if I was to look at this from the standpoint of, an attack taking place, if someone was to get onto my network, and if they were to go after some financial data, maybe in this case, credit card data, we'd have that user tagged, we'd have that credit card data tagged, and when that person who might have a stolen credential, so they're on my network with that stolen credential, but perhaps that identity is not one that is financial. TrustSec essentially can block that access based on policy. And so that, instead of setting up, barriers in a traditional approach, we're looking at the role of the user, the asset they're trying to reach in the network, and we can block it and enforce that policy whether you're coming in wired, wireless, or through VPN. And so we're seeing a lot of users seeing this as a more flexible and policy-based approach to the simple basic idea that you should be segmenting your network, but doing it, again, from the user perspective. ICE, as I referred to before, is going to give us that network-wide policy enforcement. So as I've got a distributed enterprise, I can look at identity, and I can look at the devices on the network and understand the context of who's on my network, what application they're running, where they're running it from, when, how they're running it. Again, the simple example of when I'm in the office, I can access some resources. When I'm in the coffee shop, I might be blocked from others. And we can do it at a very, very granular basis. So again, the tools to create those policies and drive segmentation based on role and then down to a very, very granular capability with ICE. And so strategic advice, encrypt your data in motion. From an encryption perspective, we want to protect that data between devices. From a wired perspective, we can leverage MACsec. From a wireless perspective, DTLS. From a WAN link, get IPsec. From a mobile device, ICE with MDM. If you look at some of the top internet providers out there, when you go to access them through a browser, 7 out of 10 of the top ones right now, you see HTTPS come up. They're encrypting that traffic from the browser back to their service. And a lot of them also are encrypting the traffic behind the service, whether it's between devices or across their global enterprise network. And the strategic advice here is that we want to leverage encryption where it makes sense to protect against spoofing, protect against snooping, look at that opportunity to do that man-in-the-middle attack, and leverage encryption to help prevent that from taking place. From a WAN perspective, a lot of users are looking at the communication between their headquarters and their branch and looking at reducing costs of expensive MPLS circuits. So maybe they need redundancy with multiple connections. Maybe they're looking at increasing The bandwidth they've got, the capabilities of more and more devices, more and more applications, more voice and videos on the network, and looking at a cost-effective way of doing that. Well, Intelligent WAN or IWAN is one way we can leverage the price efficiencies of a business internet connection with the reliability you get with an MPLS sort of connection, and actually tag applications so that, maybe my web-based apps go down the business internet route, maybe my business critical apps go down the MPLS circuit. A lot of capability and configuration there where I can tune it towards performance, cost, or otherwise. Great idea for the branch, but what we're going to do is take that and couple it with security, and we want to look at making that branch connectivity highly secure. So integrating cloud security capabilities, leveraging dynamic multi-point VPNs, looking at hardware-based cryptography, and leveraging that firewall that's built into that branch router, maybe an ISRG2 and ISO 4000. The thing to take a look at here is not only leveraging IWAN capabilities, but coupling it with security so that we can have the cost benefits of leveraging a business internet connectivity, leveraging the internet itself for the right applications, but do it with the framework and the blinders on of making sure that security is always forefront. So again, strategic advice. There's a lot of network capabilities we've talked about thus far, whether it's NetFlow, whether it's TrustSec, or encryption, or IWAN with security. Likely the infrastructure you've got today has these capabilities in it. Strategic advice is turn it on, start leveraging it, and activate those capabilities to drive more security from your infrastructure.
So one maybe quick point of commentary here too, and maybe we answer some of the questions that have come up in chat as a result. We talk about these different types of technologies, NetFlow, TrustSec, encryption, all the different components that Brian's been talking about lately are highly complementary to one another. And so when we talk about TrustSec and being able to create better network segmentation with secure group tags, it's important for us to do a couple of things. One of those is planning. So NetFlow plays a core role in being able to understand what our assets are doing so that we can better plan for how we're going to create that type of network segmentation in our businesses. One of the things that we've noticed over the course of the years when we're working with our customers is that there's a desire to understand the networks better, but candidly, a lot of the way that our functional groups work inside of businesses doesn't facilitate enough conversation for us to truly understand what the assets on our networks are doing. NetFlow is a great way for us to be able to get that type of understanding and create better policy on the front end. It then is also very useful to be able to make sure that the policies that have been put in place for that type of segmentation are being observed. Right? When we talk about ICE being able to define those particular policies, NetFlow is a fantastic audit mechanism of how we can go back in and ensure that those policies are being met after they're put in place for the host, right? We can do a check and balance whenever the systems come onto the network. Does it meet these particular set of compliance requirements? But after that, NetFlow is the enforcement mechanism to say, is this actually functioning in the fashion that it was planned to do whenever it first came on, right? We meet our compliance, all of the appropriate software is installed here, it fits the proper profile to be able to have access to these network resources, but once it's there in that particular segment, is it doing what it's supposed to do? When we talk about encryption, one of the really cool things that Brian kind of skimmed over when he was talking about that is that particularly about MACsec inside of the network, that encryption is broken and reinitiated at every single switch along that particular path. What that means is that the data is protected in motion across the wire, right? Prevents us from snooping at those particular elements, but the fact that it's opened up and re-encrypted at every single switch means that we don't lose the visibility into the actual transactions that are being carried across the LAN. So the NetFlow reporting on those particular segments is accurate about the transactions that are moving through those secured tunnels inside of your LAN. Right? We're not losing any visibility as a result of that. I think that the combination of these three components is extraordinarily beneficial. They play well together. It's not a disruptive technology at all. TrustSec being dictated by ICE and things of that nature helps to roll into the overall story. We already have an integration with ICE to be able to pull out the information for user machines and device profiles, and now we're able to combine that with secure group tags that are associated with ICE, but provided by the network in terms of reporting capabilities. It's a very cohesive strategy to be able to monitor all of these hosts as we move through the scope of your networks.
Absolutely. So high level again, you likely have this in your network today. Enable it and start using it. So one last piece of the three, the network has a mitigation accelerator. And I'll just touch on this briefly because we talked a lot about the sensor side and the detection side. Let's talk a little bit about accelerating the fix because we want to decrease that time to remediation. We want to take that 43 days that we talked about in the beginning and figure out what is it we can do in the network to remediate against threats and automate that on a global network and automate not only policy-based automation, but some of the configuring and provisioning of those of you who have to handle like the low-level details on the switches and routers, such as ACL QoS or performance routing configuration, and do it through an open, programmable, abstracted way. What we have here is basically a desire to automate to accelerate that remediation time, and do it in a policy-based way. And one approach we've got for this is with the APIC Enterprise module. It's our approach to software-defined networking in the enterprise network. And what it does, it takes us from a world where previously configuration was done box by box and manually, literally people cutting and pasting text files, potentially thousands of lines long, and creating an opportunity to make mistakes and doing it in a frankly slow fashion where we're rolling out a change across a global enterprise could take you weeks. And what we want to do is take this to leveraging a software-defined networking approach to this, leveraging automation, and doing it with the APIC Enterprise module, where we can leverage all that data that comes from network as a sensor, and then leverage it to roll out capabilities such as network as an enforcer, and actually make configuration changes based on that level of information you're getting from the network in an automated way, and literally taking it down to minutes or hours instead of days or weeks. So the controller, the APIC Enterprise module, is what gives us this ability to look at the global enterprise network and then instantiate these changes in real time. And so from a sensor perspective, it's gathering up all the information across my network. From an enforcer perspective, it's making the changes to my infrastructure. So if I wanted to roll out, let's say, an ACL update to counter a threat on my network, I can essentially push go and have that go out to all the devices that I want it to go to. I can coordinate to make sure all of my devices are in policy, and then I can integrate it. And so that if we've got something coming from Lancope from an integration perspective, we can tie that together and automate a network response to a threat that's detected on the network. So this gets us that shrinking and that remediation time down to an automated fashion. And again, this is leveraging the network itself in an automated way to counter these threats that are on the network. And so we talked about a couple things today, and just to summarize, and maybe we'll take a look at some of the Q&A here. The first step, enable NetFlow, leverage that data, send it to Lancope StealthWatch, look at those alerts on your network, and understand what's on your network, and then understand it quickly, importantly, to decrease that time that it takes to detect. Deploy segmentation. Look at carving up the network, divide to defend that network, and contain attacks as it take place. Leverage encryption where it makes sense. Again, there's a lot of capabilities in our Catalyst line with our Catalyst integrated security features. Turn them on. Leverage those capabilities. Deploy Intelligent WAN. Do it with the context of security so that you can encrypt that data, so you can filter based on email and HTTP traffic. And then look at automation, to decrease the time it takes to remediate threats in your network. So again, high level, unite the forces. Don't stop doing what you're doing today. Traditional security approaches are important. Advanced malware, very important. But start looking at that network. Capabilities are there. They just simply need to be turned on and leveraged and integrated with Lancope StealthWatch to give you the value of understanding what's on that network and looking at those alerts from the perspective of being able to detect things very quickly.